All right, let's get started with the Quizizz review. So, first question. What is the definition of a function? Now, before I look at the answer choices, the function is a relationship where for every x, there can only be one y. So for every x, which is the input, you can only have one y, which is the output. Okay, so for every x, only one output for y. So every input has only one output. This one looks good so far. Let's see. Has inputs and outputs? No, not necessarily, because you have non-functions that have inputs and outputs. X values and Y values, that's nice. That's not enough. And inputs have different outputs every time. That doesn't even make sense. Inputs have different outputs every time. Um, Not necessarily. Um, so that's the first problem. Next problem. Which set of values can represent a function? So for every x, every x can only have one y value. Or for every input, you can only have one output. All right, so let's see. Here we have 9 and 5. So this is an x, this is a y, this is an x, this is a y, x and y, x and y. All right. Well, I see that 9 repeats, right, over here and here. Right? 9 and 5, 9 and negative 5. So you can't have that. That is not an a situation that for every x there's only one y. Here I see the x values are 6, 7, 8, and 9, so they don't repeat at all, so this is the correct answer. Let's just check the other ones. Here, 3 and 3 repeat, so that's not an answer. Here, 5 and 5 repeat as x values, so that's not an answer either. Let's move on to the next one. Is this graph a function or not? So I'm going to talk real quick about something called the vertical line test. That's another way of checking if a function exists. So I'm going to draw a vertical line. All right, there's my vertical line. If it is a function, another way to test it is to see if a vertical line will cross only one point. So if you see here, the only point it crosses is over here. Only point it crosses is right there. It only crosses this relationship one time at each point. So if you were to drag a vertical line, if it only crosses your relationship once, then it is a function. So this is a function right here. Let's try another one. Is the graph pictured a function? All right, I'm going to try the vertical line test again. So I'm going to create a vertical line. Here we go. There's my vertical line. And I'm going to see what happens if I drag this over. Take a look. Here's just one example of where it doesn't pass what's called the vertical line test. Here, it crosses, and here it crosses. So when it crosses a relationship twice, that is not a function. All right? And if you think about it, the x value here and the x value here are the same. So once again, you have two x values for one y value. Two y values for one x value. It doesn't pass the vertical line test. It is not a function. Moving onward. Is the relation a function y? Well, here's your input, x, and your output, y. And x is negative 7, y is 3. When x is 11, y has two values, 5 and 8. Well, you can't have that. So it is not a function. So I'm going to eliminate the two yes choices. So now let's look at this one. No, because each x value has only one value paired with it. That's not true. This x value has 2, so this one seems untrue. No, because the x value 11 has 2 y values paired with it. Yes, that's why it is not a function. So no, and then the rest. Moving onward. Next question. Can the table represent a function or is it not a function? All right, so we have 3 and 1, -2 and -4, 0 and 2, and 3 and 6. Well, if you see, 3 repeats and has 2 values that go with it, 3 and 1 and 3 and 6. So because the x value repeats with 2 different y's, it is not a function. Moving onward. Find the output h when x equals -18. So all we really need to do here is substitute -18 for for x. So h is equal to 12 plus -18 over 6. Well, -18 divided by 6 is 3. So 12 plus, that's negative divided by positive is -3. So I end up with 12 plus -3 is 9. So the output h is equal to 9. Moving onward. Find the output y when x is 30. So here you go. Y equals 14 minus 0.5. But now we're going to replace x with 30, so times 30. All right. Order of operations, 0.5 times 30 is half of 30 is 15. So y is equal to 14 minus 15, or y is equal to -1. So when x is 30, y is -1. Moving onward. Find the output f when the input t is 7. So we have f equals 2 times 7, replacing t with 7, minus 3. So 2 times 7 is 14 minus 3, and 14 minus 3 is 11, so f is equal to 11. So when t is replaced with 7, the value for f that makes this true is 11. Moving on. Find the output y when the input x is 2. So when your x value is 2, 1, 2, looks like your y value or your output is 0, right? That's the point 2, 0. So that's your output. When the input is 2, output is 0. Moving on. Find the output y when the input x is 8. All right. Let's zoom in a little. Oops, I do not want to stop recording. Let's go into a zoom here. All right. So find the output when the input x is 8. So when x is 8, your output, your y here is 1. So the point 8, 1, right? So the output is 1. That's what we're looking for. Moving on. Question 12. Find the output y for when the input x is -5. So when x is -5, what's my y going to be? Well, if you look here, when x is -5, my y is -2. So the correct answer here is -2. Moving onward. Find the output y when the input x is -2. So when x is -2, right, when x is -2, what's my output? What's my y? Well, my y is right there, so it's +4. So the correct answer here is 4, and I don't see it, so I'm guessing, yep, there it is right there. So when x is -2, y is 4. Number 14. Rearrange the equation. I'm going to go back to the full screen view. Rearrange the equation so that w is the independent variable, or solve for u. So here's the equation. -2u plus 6w equals 9. So we want to solve for u. We want to get u by itself here. So what would I do? I would subtract 6w from both sides. So my new equation would be -2u equals, that's a 0 pair, -6w plus 9. And now I would have to divide both sides by what? negative 2. If I divide that side by negative 2, I got to divide this side by negative 2. Let's kind of make this a little more roomy. So negative 6 divided by negative 2 is positive 3w, right? And positive 9 divided by negative 2 is a negative 9 over 2. So I get u equals 3w minus 9 over 2. U equals 3w minus 9 over 2. It's right there. So all I did is rearrange the equation, solved for u. Number 15. Rearrange the equation so that x is the independent variable, or solve for y. So I have, let's give myself a little bit more room, negative 5x minus 4y equals negative 8, and I want to end up with just y equals at the end. So I can first add 5x to both sides. By doing that, I end up with negative 4y equals 5x minus 8. Now I want to go from negative 4y to just y, so I'm going to divide by negative 4. If I divide one side by negative 4, I have to divide the other side by negative 4. So positive 5 divided by negative 4 is negative 5 over 4x. And here, negative 8 divided by negative 4, and negative divided by negative is a positive. 8 divided by 4 is 2. So I get y equals negative 5/4 x plus 2. Y equals negative 5/4 x plus 2. There's my answer. And I think the last one is next. Yes, it is the last one. All right, rearrange the equation so that b is the independent variable, or solve for a. So a minus 7 equals 3, open parentheses, b plus 2. So I want to rewrite this equation and end up with a equals something on the other side. Well, right here, I got to get rid of the parentheses by distributing. So I'm going to rewrite this. A minus 7 equals 3b plus 6. And then to get a by itself, I would add 7 to both sides. So a, positive 7, negative 7 make a 0 pair, so that leaves me with just a. And on this side, 3b plus 6 and plus 7, well, 6 and 7 can be combined, so I get 3b, 6 plus 7 is positive 13, so a equals 3b plus 13. There's my answer. Hope you find that helpful. Found it helpful. Take care.